second part of the numerical is that, so it is reheated to a pressure of 5.5 bar and to a temperature of 400 degrees Celsius. The same is represented on the TS diagram. It's the same is represented on the TS diagram like this. Okay, so now you have 1 to 2 is an expansion in one turbine, that is called as the high pressure turbine. It is expanded from 32 bar. It is expanded from 32 bar to 5.5 bar. So from 410 degrees Celsius to this 5.5 bar. Now the state 2 is saturated steam. Again, at this pressure, it is reheated. It is reheated. It is reheated to 400 degrees Celsius at 5.5 bar. So after, once it reaches state 3 at 400 superheated steam, it is expanded in the LP turbine. It is expanded in the LP turbine from 3 to 4. Again, it becomes a wet steam. Now it is expanded from 5.5 bar to 0.08 bar. Now from 4 to 5, again it is the condensation taking place till 5 saturated liquid state, and 5 to 6 is being pumped to the same pressure T1 again, and 6 to 1 is the amount of heat added in the boiler. Now this is for the reheat cycle. Now again you will have to calculate the enthalpies for the various points H1 to H6. H1 remaining the same because it is at 32 bar and 410 degrees Celsius. This value remains the same. The second part, how do you find this value of H2? H2 is the Hg value corresponding to 5.5 bar from the steam table. So H2 value is 5. Hg value. It is nothing but the Hg value corresponding to 5.5 bar. Here you do not have a value for 5.5. You have for 5.4 and 5.6. We'll have to go for the interpolation and find out this value H2. Okay. So now H2 is Hg value, enthalpy of saturated steam. Thus you can find this value. Now after that, it is reheated in the turbine from 2 to 3. It is reheated in the turbine from 2 to 3. Now, you can see that at 5.5 bar and 410 degrees Celsius, this is the value of H3. So pressure is 5.5 bar, 410 degrees Celsius. You have to find the value of H3. Now TS corresponding saturation temperature at 5.5 bar is 155.5 degrees Celsius, less than 410. So that means this is superheated steam. Now for this superheated steam, we'll have to find out the value of the enthalpy H3. So H3 can be now can be computed something like this. You refer enthalpy of superheated steam table and find out the value. That is one way, like earlier. Or the second method is Hg plus Cps into T3 minus Ts. So we'll have to refer the Hg value corresponding to 5.5 bar plus corresponding to 5, what is this value of H2 plus Cps into T3 minus Ts, which is T sub minus Ts. It is 410 minus 155. The specific heat of steam is 2.01 or 2 you can take, or 1.996, something like that. So let us assume this specific heat of steam as 2.01. Now this is heat of superheat added to Hg, you will get this value of H3 as 3263.4 kilojoules per kg. So thus you can compute this value of the enthalpy of superheated steam. Now how do you find this value of 4? Again S3 must be equal to S4. You'll have to equate these two. S3 is equals to S4 and find out the value. Now you do not have a value for 5.5. So you'll have to find out this value of S3. Find out this value of S3 for the superheated steam. You do not have the value. You'll have to go for the interpolation and find out this value of S3, which comes out to be 7.824. Now SF4 and SFG4, okay, so these two values are referred for pressure of 0.08 bar. These values are for 0.593 and 7.67. So S is equals to, which is for the superheated steam, its value is 7.824, must be equal to SF4 plus X4 into SFG4, okay. So once you substitute these values, now you get this value of X4 as 0.946. Now H4 is equals to, enthalpy of wet steam is equals to HF4 plus X4 into HFG4 corresponding to 0.08 bar. You have these values from the steam table. Okay, substitute these values, we'll get the value of H4. Then H5 is the value of HF corresponding to this pressure from the steam table, which value is 173.9. So 173.9 is the value of H5. And how do you find this value of H6? As usual, like WP, you'll have to find out first VF5 into P1 minus P2. So VF5 corresponding to this pressure is 0.001008 meter cube per kg into 32 minus 0.08 into 10 to the power 5 divided by 1000. This value comes out to be 3.21 kg. Again, this is equated to difference in the enthalpies H6 minus H5. H5 is known, H6 is not known. So find this value of H6 by substitution. It is 177.1 kilojoules per kg. So thus you have already computed this value of X4. Now H6 also you have found out. So all these values H1 to H6 have been found out. Now you'll have to find the value of W net. W net is work of expansion in HP turbine plus work of expansion in LP turbine minus the pump work. So HP turbine, it is the difference in the enthalpies H1 minus H2 plus LPT turbine H3 minus H4 minus WP. Substitute all these values, it comes out to be 1313.3 kilojoules per kg. Q1 is calculated, heat is added from 6 to 1 and 2 to 3. So it is H1 minus H6 plus H3 minus H2. Substitute the values and find out this value of heat supplied in the boiler. Now efficiency is W net by Q1 into 100. So thus you substitute these values, efficiency comes out to be 36.6%. So thus you can compute these values of the efficiency and the dryness fraction. So this procedure of calculation remains the same for all the numericals. First and the foremost important thing is find out enthalpies and calculate these values of WT and WT, WP and Q1 so that you can compute the efficiency. So like this you can solve the numerical on the heat cycle. So thus we have solved a numerical, the third numerical considering case 1 and considering case 2. Because one was a simple cycle, Rankine cycle. Second one was for a reheat cycle. So thus we have computed these values.